You know, every time you use a cloud service or fire up an app on your phone, you're plugging into this massive, invisible fabric that connects everything inside a modern data center. It's what gives us all that incredible speed and flexibility. So today, we're going to pull back the curtain and demystify two of the key technologies that weave this whole fabric together: VXLAN and EVPN.
All right, so here's our game plan. We'll kick things off with the big problems that plagued old data centers. Then, we'll look at the new physical blueprint that totally changed the game. From there, we'll get into the core ideas of underlays and overlays, and then, the really cool part, how VXLAN actually builds the virtual tunnels and how EVPN acts as the network's brain. And finally, we'll see what it all unlocks.
You know, to really appreciate just how revolutionary the new stuff is, we have to understand why the old way of doing things just broke. Why couldn't those traditional data center networks keep up with modern demands?
For decades, networks were built kind of like a pyramid. You had your access, aggregation, and core layers. And that was fine when most of the traffic was north-south. You know, from a user out on the internet, down into a server, and then back out again. But then, server virtualization came along, and suddenly, you could run dozens of virtual machines on just one physical server. All these new applications were constantly talking to each other inside the data center. This created a gigantic traffic jam of east-west traffic that the old pyramid design just couldn't handle.
And the pain points were real. Slow convergence. That just means if a cable got unplugged, the network would take forever to figure out a new route, causing outages. Unnecessary broadcasts. Think of that as network-wide spam, just flooding every single device with traffic it didn't need. It all added up to a system that was fragile, inefficient, and an absolute nightmare to manage.
So, the problem was pretty clear. And the first step toward fixing it wasn't some fancy new software. It was physical. The entire blueprint for how you wire up a data center had to be completely redrawn. And this picture says it all. Out with the old, rigid pyramid and in with this new design called leaf spine. The idea is actually super simple. Every leaf switch, that's where the servers plug in, connects directly to every spine switch. That's it. This creates a really simple, flat fabric where it's always just 2 hops to get from any server to any other server.
And the benefits are huge. The performance is predictable because the path is always the same length. Need more capacity? Just add another spine or leaf switch. It's that easy. And maybe best of all, we get to throw out old clunky protocols like spanning tree, which literally used to shut down half your network links to prevent loops. Instead, with this design, every single connection is active all the time, which dramatically increases your available bandwidth. Okay, so we've got a much better physical foundation. The next step is a huge conceptual leap. This idea of separating the physical network from the logical services that run on top of it. This is where we get into underlays and overlays. So the underlay is simply our physical network. It's that high-performance leaf-spine fabric we just talked about. The actual switches, the cables, and the basic IP routing that connects them. Its only job is to provide simple, reliable transport from point A to point B. Think of it as the public highway system. The overlay, then, is a whole bunch of virtual networks that we build on top of that physical highway. This is where we create all the logical connections and policies that our applications actually need, and it's completely independent of the physical roads underneath. And this is really the best way to think about it. The highway system, our underlay, doesn't know or care what's inside the delivery trucks. The private courier service, our overlay, can create its own direct virtual routes between any 2 buildings, using the public roads without anyone else even knowing the delivery is happening.
So how do we actually build those private routes for our courier service? Well, the technology that creates these virtual tunnels is called VXLAN.
VXLAN stands for Virtual Extensible LAN. And its main job is to let us do something that used to be incredibly difficult. Take a simple Layer 2 network, like a basic VLAN, and stretch it across our big, sophisticated Layer 3 routed fabric.
It pulls this off with a really clever trick called encapsulation. It's just like putting a letter in an envelope. The original data from the server is the inner payload, the letter itself. VXLAN then wraps that letter in a whole new envelope. This outer envelope has a new IP address for the underlay highway to read, and a special VXLAN header that says which virtual network it belongs to. The physical network only ever looks at that outer envelope.
Now, this one simple trick has staggering implications for scale. That little VXLAN network identifier, or VNI, allows for over 16 million unique virtual networks on the exact same physical hardware. This completely blows the old limit of about 4,000 VLANs out of the water. It was a total game changer for cloud providers. So, we have this incredible ability to create millions of virtual tunnels. But how does a server on one side of the building know which tunnel to use to find a server on the other side? We need a brain for the operation, and that's where EVPN comes in.
Right, so the old way of finding things was this chaotic method called flood and learn. A switch would basically scream out to every other switch, "Hey, does anyone know where this server is?" It was noisy, inefficient, and just didn't scale. The new way, with EVPN, is like giving the network an intelligent GPS or a central, constantly updated address book. No more shouting.
And this is the critical partnership. VXLAN is the data plane. It builds the tunnels and actually carries your traffic. EVPN is the control plane. It's the intelligence that tells the traffic where to go. It actually uses BGP, the same incredibly powerful and scalable protocol that runs the entire internet to share that address book information. So when one server wants to talk to another, its switch just does a quick lookup, finds the right address, and sends the packet down the correct VXLAN tunnel. It's just precise, efficient communication.
Okay, let's put all the pieces together. We've got a fast, leaf-spine physical underlay, we've got VXLAN creating millions of virtual tunnels on top of it, and we have EVPN providing all the intelligence to direct the traffic. So what's the real-world payoff of putting all this together?
Well, this modern fabric is what unlocks all that agility we expect from the cloud. It means you can move a running virtual machine from one server to another anywhere in the data center without dropping a single connection. It lets you securely host thousands of different customers on the exact same hardware. And it opens the door to one of the most powerful use cases of all.
And this is the ultimate payoff: data center interconnect. We can use the exact same technology to stretch these VXLAN tunnels not just across a building, but across the entire globe. We can now treat 2 or even 10 physically separate data centers as if they were one single, logical pool of compute and storage. This is the absolute foundation for modern disaster recovery and global applications.
And really, that powerful idea of abstraction, of separating the virtual from the physical, is the key takeaway. VXLAN and EVPN didn't just build a faster network for today. They created a foundation that's fundamentally more agile and programmable, ready for the demands of tomorrow that we haven't even thought of yet. So the next time you use a cloud service, just remember that invisible, intelligent fabric humming along underneath it all, making our connected world possible.